Hi everyone. So in this lesson we're going to go over 1.4, which is on partitioning a line statement. It's similar to midpoint, except with midpoint you're cutting your line exactly in half, whereas when we partition we're going to split it some other way. So one side's going to be bigger than the other one. Okay, and they'll always tell you your ratio that you're going to use. Okay, so the problems would look something like this, where it says to find the coordinates of the point that partitions or splits the line. And it always says from a directed line segment saying like this is your first point and that's your second. So it's starting here, from here to here, like just know first point, second point. That's what the directed part means. And then it says and it partitions the segment in a 2 to 1. So that means that we're going to put the point somewhere on this line, wherever that's going to be, where this piece here is going to be twice as big as that piece there. Okay, so I know you're probably thinking distance formula, which if the line was horizontal or vertical, we could use the distance aspect of it, but that's not exactly how we're going to do it. Okay, so we're going to start by finding the ratio. So you're going to be given the ratio of the left piece to the right piece. So that's what this is. Okay, so you're going to be given that part. So if they tell you that the ratio of the two pieces is 2 to 1, we need to find the ratio of a P to a B. So that's what we're looking for. So that's where this comes from. This is a P to a B. So let me draw a picture. So if this is A and B, and this is P. So they give you this compared to this. Oh, JK. They'll give you this compared to this, but that's not what it says. But that's what we need to find. We need to find AP to the whole thing. Okay? So the given ratio is AP to PB, but we want to find AP to AB. Okay? So that's what that's talking about. So we find that ratio, we find the difference of the coordinates. So we subtract the second one, or the first one from the second one for x and y. And then we multiply those differences by the ratio of AP to AB. And then we add those answers from that to the original point. And that's it. Okay, there's also another way to do it where you use this formula. And I'll show you one like that too so you can see the difference. I usually do this method, but if you're good at memorizing formulas, then that might be the way to do it. Okay, so what we're going to do first is we're going to find our new ratio. So remember, we want it as the whole thing. So right now we have, this is C and D, and our point P is somewhere on there. This is 2 and 1. So this is 2, and then the whole thing would be worth 3. So our new ratio would be 2 to 3. Okay, so here they say like the ratio is m over n. So one way to remember to find that would be m over m plus n. So whatever the two numbers are, you add them together in the denominator, and then your first number is always your numerator. So that might be a shortcut for you. Okay, so we did that first part. We found our new ratio. Step 2 says to find the differences. So for x, my x2 is 6 minus my x1, so that's 9. For y, I have 1 minus negative 2. So then step 3 says to multiply those differences by your ratio. So I'm going to times this by 2/3. Okay, so remember we can put this over 1 and multiply straight across. So that's 18 over 3, which is 6. Okay, so let me explain what these numbers mean a little bit before we move on. The 9 that we got here means that our C and D are 9 apart. Like if you counted over, you would get 9 to get to here. So it's kind of like, you remember in slope, the rise and run? Okay, so that's our run is 9, and our rise is the 3 that we got from here. But we don't want to know the whole distance between them for the x values, we want to know how big 2/3 of that distance is. So that's why we multiply it by 2/3. So what this tells us is to get to our partition point, I'm going to move on the x-axis, or the horizontal distance, 6. So I'd have to go over 6 from there. So that would put me here. Okay, and then to figure out how much to go up to get to the point, you'd have to finish solving this, which we get 6 over 3, so that's 2. So that means if I go x distance of 6, y distance of 2, then that point right there is our partition point, point P. Okay, so we usually don't do it with a graph. So the way you would find the ordered pair for that point is you take that distance you have to travel, that's 2/3 of your line, and you add it to your original point, which is what step 4 says. So my original point C was at -3, -2. My change in x is +6, and my change in y is +2. So that's going to give me my new partition point of 3, 0, which is what we have here. And that's it. So what we're doing is trying to find that ordered pair that represents the point that's going to split this line segment, where this side is twice as big as that side, 2 to 1. Okay? That doesn't mean that the distance between C and P is 2. That just means that the distance here is twice as big as there. And if we plugged it into the distance formula and found the distance for each part, they would come out twice as big. Okay, so that's pretty much it. I wanted to show you, though, what it would look like if we used the formula instead of doing it like this. Okay, so what we would have, I listed what our stuff is. So M is 2, N is 1, there's our points. Here's the formula, and then we just plug it in. So I plugged in my M, N, X2, X1, M plus N, M, N, Y2, Y1, M plus N. And then once I simplify it, I get that. So I did the multiplication, then I do the addition, then I do the division, and I get my point. So if you like formulas better than steps, then maybe this is the way that you guys should do it. I like doing it the other way. It doesn't matter. Whatever way you can figure out the right answer is the way for you. Okay, so let's look at some more examples. So for number 2, same deal. So I'm going to do it with the steps. If you want to try it with the formula, go ahead. But I'm going to do the steps. So first we need to find our ratio. So remember we said it's M over M plus N. And here's M and N. So this would be 2 over 2 plus 3. So our new ratio is 2/5. Okay? So now we need to find the difference in x. So remember, you always start with the second point first. So 5 minus -3. So this is 8. And then we're going to times it by a ratio. So times by 2/5, which is 16/5. And so it's not as pretty as the last one, and it doesn't come out to be a whole number, but that's okay. So in your calculator, do 16 divided by 5. So we end up with 3.2. So now we'll do the same thing for y. So y2 minus y1, 0 minus -4. It's 4 times our ratio. So remember, over 1, so that's 8/5, which is 1.6. So remember, these represent how far we're moving from that original point. So now we have to take our original point and apply our change. So I'm going to move to the right 3.2, and I'm going to move up 1.6. So that means our partition point is at 0.2, -2.4. And I know that this is to the right because it's a positive x value. If it was negative, that would move it to the left, and this is to up because it's a positive y value. Okay, so that's it for number 2. Why don't you guys try examples 3 and 4? Okay, maybe do one with the formula and one with the steps that we just did. And then when you come back, I will show you the answers for those and go over them. So pause your video, please, and do examples 3 and 4. Okay, so for example 3, our ratio was 4/5. I subtracted x's, y's, multiplied them by our fractions. These were our changes. So my x was positive, so I added it to my x coordinate. My y was negative, so then you'll subtract. So that would be our partition point for example 3. For example 4, We had 1/4 as a ratio. Subtract the x's, multiply by the ratio, change it to a decimal. Subtract the y's, multiply it by the ratio, change it to a decimal, and then take those numbers and add or subtract them to your original point. So we get 2.5 negative 0.75. Awesome. Make sure if you had questions on 3 or 4 that you write them down so we can go over them, okay? So let's look at example 5. So this one's a little bit different. It says that the line segment GH is divided by point D, so that's our partition point, and the ratio of 1 to 4. Endpoint G is at negative 3, 2, and point D, your partition point, is at 2, 12. So they didn't give us what the other endpoint is. So remember when we did these with midpoint, we kind of just counted. So it's going to be the same deal here, but we just have to remember that that point is not in the middle, so it's not equal on both sides. So I'm just going to sketch a segment. Okay, so we have G, H, and point D is our partition point, and it splits it in 1 to 4. So that means the first part's going to be worth 1, and then the second part's going to be worth 4. So it's going to be a lot closer to G. So that's why I'm going to put it over there. So this is 1 to 4. Okay, so I'm going to fill in my coordinates. So G was at negative 3, 2, and D is at 2, 12. And this is what we're trying to find. What is our point H? Okay, so if we take a look at the x coordinate, we go from negative 3 to 2. So what are we changing to get from negative 3 to 2? Good, we're at add 5. So here, to get over here, we're going to have to add something, but it's going to have to match what our ratio is. So if this part's worth 1 and that part's worth 4, we'd have to add 4 times as much as what we added here. So we would add 5 times 4, or 20, to get to that. Okay, so with the midpoint we just added the same thing, but here this part is 4 times bigger, so we're not adding the same thing. We're adding whatever our ratio is. Okay, so our point would end up being 22. This is 20 plus 2, 22. Okay, so if we take a look at our y coordinates, we go from 2 to 12. So here we're adding 10. So to get over here, we would have to add 4 times that much. So we add 4, or write it the same way, 10 times 4, so we're going to add 40. So 12 plus 40 is 52. Okay, so remember we're timesing it by 4 because that's how much more this line is worth. Okay, so when we're only going 1, we add 10. If we're going 4 times that much, we would add 40. So that means that our point H is at 22, 52. And that's it. Okay, let's quickly try to get the examples in the back done. So for these, it's a little bit different because they give you all 3 points, but now we have to find what the ratio is. Okay, so I again draw a sketch to see the difference in the coordinates, and then we make our ratio. Okay, so we have A, B, so endpoint A is negative 3, 2. Our other endpoint is 6, 11. Endpoint P partitions the point at 0, 5. So I don't really know where that point's going to go, like how, what the ratio is, so it's hard to draw the accurate picture, but I know 0 is closer to negative 3 than it is to 6, so I'm going to put P closer to A than B. Okay, so we're going to do the same thing and see how much they're changing. So if I look at my x coordinates, to get to here, I add 3. To get to here, I would add 6. So it looks like it's doubling. So 3 to 6, what do we reduce? We'll talk about that in a second. So let's talk about our same thing for the y's. So to get from here, I added 3. To get to here, I added 6. Okay, so they wanted a ratio of AP to PB. So our ratio, so they said AP to PB. So how big is AP? Well, we got that it changes by 3, and then this one changes by 6. So that means we get 1/2 because I reduced by 3. So our ratio is 1 to 2. Awesome. So can you guys pause your video and try example 7, and then I'll talk about it real quick and we'll be done. Okay, so this one ended up having decimals, but the ratio still works out the same. So our x's, or for the x's we changed by 6 and then we changed by 2. Our y's changed by 4.5 and then 1.5. But no matter how you do it, if you reduce these, you end up getting 3 to 1. So our ratio is 3 to 1. And that is all. We'll practice more of those in class. Remember to write down any questions you have. Werner out.